A solid sphere of radius r carries a charge q plus q distributed uniformly over its volume. A very small point-like piece of it of mass m, okay, of mass m here, gets detached from the bottom of the sphere and falls down vertically under gravity. This piece carries charge q. If it acquires a speed when it has fallen through a vertical height, basically y, then assume the remaining portion to be spherical. So what should be the value of v square? So in this problem, this is our sphere, and there is a particle which has been detached from it, and it is falling under gravity as well as the effect electric field due to the sphere. So the charge is at this position initially, and its speed is initially 0. Mass is given as m. Now when this particle reaches to some position, let's say at a height y from this one, then it has a speed of v. So the question is why it has acquired speed v. Answer is because of gravity and because of the force due to the sphere here. So because of this sphere, if we write the initial here, let's say this is our reference line. So if I write its initial energy E1, then that is how much its potential energy, that because you can see why I am using conservation of energy, you need to understand, because only conservative forces are there in the system, so we can easily use the conservation of energy concept over here. So E initial will be how much? E initial will be a potential energy plus kinetic energy. So potential energy, this is the reference line, so gravitational potential energy is 0 here, and the electrostatic potential energy is how much? K q q by r, and kinetic energy is also 0. So this is E initial. At this position, if I write E final, then its potential energy is K q q by r plus y, okay, and potential energy due to earth is minus mg y because it has fallen down, and kinetic energy is how much? That is half m times us, let's say this is v square. So we have to equate them. As total energy is conserved, I can write as total energy is conserved, so because only electrostatic force is involved here, so we can conserve the total energy. So E initial equals to E final, and let's substitute this K q q by r equals to K q q by r plus y minus of mgy plus of half m v square. So if I write in terms of v square, then I will get v square equals to 2k q q 1 by r minus 1 by r plus y divided by m minus of minus will become plus 2gy. So this is what we have got. Now if we simplify it, we will get 2kqqm, this is r plus y, and r here, and this will become y simply plus 2gy. So we can take y common here, so we will have y, we took common, and 2y we took common here, so we will have k q by mr r plus y. So k is basically 1 upon 4 pi epsilon naught k cube mr r plus y plus of y plus of g. So v square is 2y k q q, r is also there, no, r is not there in it, and r plus y, if we see which option is there, so kq mr r plus y, k is 1 upon 4 pi epsilon naught. So if we check the option first one, 2 y q m r r plus y g, so correct option is option 1.